Ever wondered how your computer pulls off its magic tricks? Well, today we're pulling back the curtain on one of the greatest illusions in all of technology.
I mean, think about it. It just doesn't seem possible, right? You have a fixed amount of RAM, let's say 8 gigs, but you're running a massive video game or some complex editing software, plus who knows how many browser tabs. How does all of that fit?
Well, the answer is it doesn't. The secret is that it's all an illusion, a really, really brilliant trick that your operating system performs constantly. It's a master illusionist, and it convinces every single program that it has all the memory in the world. Okay, let's dive into how it pulls this off.
So to get this trick started, the operating system begins with a foundational lie. It looks at every program you run and gives each one its own private, isolated universe of memory to play in.
This is the key concept right here, virtual memory. And that word decoupled is everything. It means what the program thinks is memory is completely separate from the actual physical RAM chips inside your computer. The operating system creates this perfect little bubble for every program. And the difference between these two worlds is, well, it's night and day. On the left, that's what your program sees, this beautiful, wide open, perfectly organized highway of memory that goes on forever. But on the right, that's the messy reality inside your RAM, a chaotic, shared parking lot where little pieces of all your different programs are squeezed in wherever there's an open space. So how on earth does the OS manage that chaos while keeping up the illusion of that perfect, orderly highway? The secret is a brilliant little system called paging. Instead of trying to handle memory as one giant, unwieldy thing, the OS gets smart. It just chops everything up. The program's imaginary memory gets cut into these little chunks called pages, and the real physical RAM gets cut up into chunks of the exact same size called page frames. Suddenly, everything is standardized and much, much easier to manage.
And here is the absolute best way to picture what's happening. Your physical RAM, that's a tiny exclusive stage. Your hard drive, that's the enormous backstage warehouse. The operating system only brings the actors, the pages of code and data, onto the stage when they are absolutely needed for the current scene. Everything else just waits backstage.
Of course, a show like this needs a director, or maybe a stage manager. And that's where the Memory Management Unit, or MMU, comes in. This is a special piece of hardware, usually right there on the CPU, and its one and only job is to be the stage manager, translating the program's pretend addresses into real, physical addresses in RAM. Let's just quickly trace how this works. Your program needs some data, so the CPU asks for it at a virtual address. The MMU catches that request and breaks it into two parts: which page it's on and where it is inside that page. That's the offset. Then it looks up that virtual page number in this master list, called a page table. The table tells it, oh, that page? It's currently on stage in physical frame number 7. The MMU just combines that physical frame number with the original offset and boom, it has the real address. And this happens for every single memory access, millions of times a second. It's just unbelievably fast. Okay, that's all fine and good if the page you need is already on stage. But what happens if the program needs an actor who's still backstage waiting on the hard disk? This is the critical moment, right? The MMU goes to look in its page table and the table says, nope, that page isn't in RAM right now. What happens then? This triggers something called a page fault. And please, the most important thing to know is that this is not an error. Don't let the name fool you. It's a totally normal, expected part of the system. Think of it as the stage manager whispering into a headset, hey, we need the actor from dressing room B. Go get him. The MMU basically raises a flag and hands control over to the operating system. And the OS just springs into action. It pauses the program for a split second, finds the page it needs on the hard drive, and then finds a page in RAM that isn't being used much. If it has to, it'll kick that old page out, sending it backstage to the disk. Then it loads the new required page into that empty spot. It quickly updates the page table to say, hey, the page you wanted is now here, and then it just restarts the original instruction. And the best part? The program has absolutely no idea any of that just happened. To the program, it was completely seamless. So you might be thinking, wow, that is a lot of complex choreography. Why do computers go through all this trouble? What is the grand finale? What's the payoff for this incredible illusion? Well, there are some huge benefits. First, the obvious one, you can run gigantic programs because only the bits and pieces you need at any given moment have to be in RAM. Second, you get that smooth multitasking we all love because RAM can hold the active pages from lots of different programs all at once.
Third, and this is crucial, it's about protection. Because every program is in its own little universe, it can't accidentally or maliciously mess with another program's memory. And finally, it's just incredibly efficient. Nothing gets loaded until it's actually needed. You know, the computer scientist Andrew Tannenbaum really sums it up perfectly here. He says that virtual memory creates this powerful new idea, the address space, which is just an abstraction of the messy physical hardware. It's all about taking something complicated and limited and making it seem simple and infinite for our programs. And really, this whole amazing dance of virtual memory, it's just one act in the incredible circus your operating system is running every single second. It's juggling this, scheduling what the processor works on, handling your mouse clicks and keyboard taps, all of it happening invisibly right now.
So the next time you fire up a huge application on a computer with what seems like not enough RAM, you'll know the secret. You'll know about the beautiful illusion of virtual memory. And it really makes you wonder, doesn't it? What other incredible tricks is your computer performing for you right at this very moment?